All right, guys. So, kind of some terminology, if you will. First of all, might help to have the pencil out. $277, I believe, will go to.
Yeah, thanks.
Okay. All right. Obviously, we'll be working a lot on the X and Y axis with Trig. X-axis, Y-axis. We'll talk a lot about quadrants. Okay. Quadrant 1, 2, 3, 4. 3's down here, and then 4's down here. So we'll work a lot with quadrants. Okay. We'll work a lot with angles. Yes.
So this is just a random question, but isn't it like, and I forgot what it's called, but like when it's 1b, it's 1 minus 5 for the quadrant?
Oh, for Roman numeral?
Yeah.
Yes, yeah. Yeah, I don't know why I always just visualize those as Roman numerals where I don't just write the numbers quadrants 1, 2, 3, and 4. I don't know, but yeah. So yeah, 1 before b is 1 less than 5, so yeah. Side note, do you know this is the first time ever they would not be using Roman numerals for the Super Bowl?
Yeah.
Really? No?
Just to be Super Bowl 50 now.
Just, yeah.
50.
And I think they're just doing it for this year. I think next year they're going back to LI.
For this year would be the Super Bowl L, right?
Just be Super Bowl L.
Be kind of dumb.
Yeah. Yeah, so anyway.
Super
Side
Bowl.
Yeah. It'll look like, yeah, Super Bowl with an extra L there. That's good. So anyway, yeah. Complete side note, glad that's on the video. That'll be good. Anyway, we'll talk a lot about angles too, okay? And when we're working with angles, we always start on the positive x-axis, okay? So this is kind of like 0 degrees right here, all right? So here's the origin. An angle that would be at 0 degrees, obviously, is not even really an angle, okay? It's not measurable, it would be 0 degrees. But 0 degrees is like your positive x-axis, okay? If I have an angle that's between 0 and, obviously this then has to be 90, okay? But this would be an angle in the first quadrant, okay, right here. When we talk about angles, we always measure them from here, okay? So this is like the initial side of the angle. You might see the word initial side. And then this is the terminal side, okay? So initial side, and then this is the terminal side, okay? And then the angle that is created, that is always the angle that we're going to be talking about. So we got initial side, terminal side. An angle is created by 2 rays. It's always measured from the positive x-axis. If you had to guess what degree of angle we're looking at there, what would your guess be probably? 45, 50, okay, somewhere in there, all right? Sometimes the angles become very large, all right, and you might get an angle that's over here in the second quadrant, okay? Now, even so that this angle is measured all the way over there, you know, so roughly, if you had to guess that angle, what might your guess be?
160, 170.
160, 170, somewhere around in there, okay? Even though the angle is measured as 160, as 170, we will always end up working with what's called the reference angle, or the angle between the terminal side and the x-axis, okay?
Does it look the same as theta?
Yes, it's supposed to be the same as theta. So that is our reference angle. A reference angle is always the angle that's created by the terminal side and the x-axis. Okay? So even though this maybe is a 160-degree angle, when we start doing some trigonometry, we're not going to be really working with 160, because when you create you couldn't really create a right triangle with that 160-degree angle, right? Okay, if we want to use right triangles, we can't use 160 degrees as that angle, so we end up using what's left over, 20 degrees, and we'll make our right triangle right there just with that one. Okay?
So all our stuff will be under
90 or below.
Yes. Yep, all our stuff will be 90 or below. And if you think about it, it ends up working the same. Okay? So let's say this was 160 and this ends up being 20 degrees here. Alright? Just because we'll be working with a 20-degree angle and you're thinking, well, 20 degrees is not 160 degrees. Well, let me show you. You're going to get the same values, okay? Because, first of all, a 20-degree angle, whether the 20 degrees is right here or the 20 degrees was in quadrant 1, wouldn't this side length be exactly the same, whether it's right here or right over here? It's a 20-degree angle, right? Okay? And then, in fact, they'd both be positive, wouldn't they?
Yeah.
Whether this is a positive y value here, also a positive y value here, if I drew a 20-degree angle in the first quadrant. Okay? And even this distance is going to be the same, the x distance, except it'll be negative. Okay? The length of this side, the x part of it, would be the same as if I drew it over there in the first quadrant, except instead of being positive, it's going to be negative. Okay? So it doesn't matter, even though we started with a 160-degree angle, you'll start working with actually just the 20-degree angle or the reference angle that's left over when you go to do all your triangle stuff. Okay? So reference angles are always going to be less than 90 degrees, and that's what we'll be working with. Okay? Alright, that's a reference angle. And obviously we can get into angles that are larger than 180, okay? We can go all the way here into the third quadrant, or we can go all the way into the fourth quadrant, okay? And either way, we'll be working with the reference angle. Alright? So, for example, let's say I was going to draw a 300-degree angle. Alright? If my angle is measured at 300 degrees. Where would I draw the terminal side of that angle? What quadrant would I draw the terminal side? Anybody? 4. Okay. So I'd start here at 0, 90, 180, 270, so I end up drawing it right here. Okay. Where is my reference angle and what measure is the reference angle?
Up and to the right of the...
Here's my reference angle right there. It's always between the terminal side and the x-axis, the closest x-axis. Obviously there's an x-axis over here, but if you go over there, then you got something.
What if it was at like 270, where would the reference angle be?
The reference angle just stays 90 then.
Okay.
Yep. Okay. So there's my reference angle, okay, and then what is the measure of that reference angle? Well, this is 300, and all the way around is 360, what must that little part have to be? 60 degrees. So we'd have a 60-degree reference angle if we were working with a 300-degree angle. Okay? So yeah, it's 300 degrees to right there, but we won't be working with a 300-degree angle. We'll just work with that leftover reference angle, so therefore we can work with right triangles. Okay. Without drawing a picture, what's the reference angle for 220 degrees?
140.
What's the reference angle for 220 degrees?
Just kidding.
I hear a 40.
Maybe a 40.
Is like 40?
Yeah.
What quadrant is 220 in? Third quadrant, right? So 90, 180, and then 220 would get me down here somewhere. Well, we're going to look at what's the measure of this part right here, always back to the x-axis, okay? So if we are at 180 and then we went up to 220, well, how far away did we go from the 180? 40 degrees, so you got a 40-degree reference angle right there. Okay? So do you guys understand the word reference angle for the most part now? Yeah. Okay? You can also go around the circle more than one time, okay? Like I could talk about a 390-degree angle. Okay? Derek?
Here, 30-degree reference angle.
It would be a 30-degree reference angle, okay? Because 90, 180, 270, 360, and then it get me right back up here, okay? So it looks something like this. 390 degrees would get you all the way around the circle once, and then plus another 30 degrees, okay? So there's kind of an example of a 390 degree angle. If you start getting angles that are larger than 360, okay, honestly you won't really work with that angle much. You will just start to think, okay, well really a 390 degree angle is essentially the same thing as a 30 degree angle, isn't it?
Yeah.
I mean, you don't have to draw this part here saying you went around the circle more than one time, but I was just showing you that you did. If I just said draw a 390 degree angle without having to put that on there, wouldn't you just essentially be drawing the same thing as a 30 degree angle?
Yeah.
These two angles here are called coterminal angles. Coterminal angles. Okay. Which basically means their terminal side is in the exact same spot. The terminal side of a 30 degree angle is right here. The terminal side of a 390 degree angle is also right there. They're in the same spot. They create the exact same angle. Okay? 750 degrees. Same thing. Go around the circle
Twice. With the 30.
360, 720, another 30 more on top of the 720 would be 750 degrees. So 750 would also be coterminal with this.
So 1,110.
1,110 would be coterminal with that. How many coterminal angles are there?
Infinitely.
Infinite. Okay.
36,030.
36,030, yes. That would be going around the circle 1,000 times and then adding another 30 degrees, right?
Well, 100.
Or no, 100 times, yes, 100 times, yeah, sorry. Okay, so, there are lots of coterminal angles. You'll have some problems that'll say something like this. Identify all the coterminal angles of 50 degrees.
What? How do you do that?
Okay? Obviously you can't list them all, right?
So would you do?
So what we write is we write 50 plus 360k, where k is an integer.
Also, it's not 36,000.
Right? And what that is saying is if you want to identify all angles that are the same as 50 degrees, well, start with a 50 degree angle and just add 360. Add 360 again. Add 360 again. Or subtract 360. Go backwards. Okay, we can have negative angles too. We haven't really talked about that yet. Alright? But by adding 360 degrees to 50, what are you doing essentially?
Just going around it.
Going around the circle one time and end up in the exact same spot, right? Well, if you do that once, you end up in the same spot. Twice, 3 times, 4 times. If you do that any integer number of times, you still end up in the exact same spot, right? You guys with me on that visually? So the way you can represent every single coterminal angle along with 50 degrees is just say 50 plus 360k, where k is an integer. You have to say where k is an integer. Because if k is a decimal,
So it's like 1,000.
then you're not adding a full circle. You with me on that? You've got to add a full circle to get back to the same spot. If you only add half of a circle, you're not at the same spot and therefore would not be at a coterminal angle. Okay?
Why did they choose K?
Why they choose k, I don't know.
These might look like 360,000.
Oh, yeah, like, I'm with you. Yeah, I don't know. They do. Yes, go ahead.
So does it have to be here, or can we just put a variable and you'll know the same thing?
It's fine, whatever.
Okay.
Yeah. Let's see, I got to do quadrantal angles yet. Okay, we've talked about them a little bit. Quadrantal angles. Okay. quadrantal angles are not really in a quadrant, okay? They're on one of the axes. So like 90 degrees is a quadrantal angle. 180 degrees, 270 degrees, 360 degrees, 0 degrees for that matter. Okay? When we hear me talk about quadrantal angles, I'm just talking about angles that occur right on the axes. Okay? Negative 90 degrees, negative 180 degrees. Okay? Negative 180 would be like this, guys. It's just going backwards. Negative 180 degrees.
What about like,
It shows it in the book on the middle one, negative 140.
what about like 430?
430? No. 430 would
Oh, no,
be
430, no.
450.
450, yeah.
450 would be a quadrantal angle.
Oh,
Yep.
it's just not 133.
Yeah, I keeps going forever, obviously.
Yeah.
Okay. Yeah, I suppose I should talk a little bit more about negative angles. 90 degrees would be the same as what negative angle? And when I say the same, 90 degrees would be coterminal with what negative angle?
Negative 270.
What do you guys think of his answer? Negative 270? Would that
No.
put you in the exact same spot as 90 degrees?
Yep.
Because negative 90, negative 180, negative 270 would get you right here, which is the same thing as a positive 90 degrees.
It's okay.
So they would be coterminal with each other. 90 degrees, negative 270 degrees, those are coterminal. They're in the exact same spot. Okay?
So negative 540.
Making them think.
Just kidding. It would actually be negative 630, right?
Negative 360 plus another negative 270.
Don't make him think on camera.
630, yes. Negative 630.
Don't make them think on camera.
Yeah, come on, guys. Okay. If you've looked closely at the reading, they talk about degrees, minutes, seconds. I'm not going to do anything with degrees, minutes, and seconds. It's kind of how they used to basically take a degree and split it into smaller chunks. It's like decimals or parts of a degree. I think they used it more in nautical times when they're out, on boats and things like that. I'll set your heading at 40 degrees, 20 minutes, 30 seconds. It's like 40 degrees and a little bit more. Okay. We don't work with that really at all in here. You don't see it really on standardized tests, so that's why we really don't include it. It's not part of our course, so we're not going to do the degrees, minutes, seconds part, so don't worry about that. Otherwise, I think you'll be in pretty good shape. A quick review, one more thing we've talked about already. You don't need to write this down again, okay? But if I do, I have a circle, okay, and I pick a coordinate, and I call it XY, okay? Do you remember making a right triangle with this coordinate?
Yeah.
You like draw the radius.
Yep, do it here, draw the radius. Here's your X, here's your Y, and then what do we call that? Just R, right?
Yeah.
Okay. X squared plus Y squared would equal R squared.
Yep.
Okay. We've put this in your notes before. If we call that theta right there, okay, the sine of theta would equal what again?
Y over R.
Sine is your Y over R. Cosine is
X over R.
X over R. And tangent is
Y over X.
Y over X. Okay. I just want to put that in your head again. You won't really need it for today's assignment, but maybe as we move forward tomorrow a little bit, Okay? The biggest thing I want you to start thinking about is sine always ends up being your y value. Sine has everything to do with your y value. Cosine has everything to do with your x value. Okay? And tangent is always y over x. Okay? So just putting that in your head, reviewing it a little bit again. We drew it previously. Okay? Now in this particular case, what values would end up being negative? Sine, cosine, tangent. Which of those would be negative?
Cosine.
Cosine would be a negative value for sure.
Sine.
Sine would be a negative value.
No, tangent would be positive.
Why would tangent be positive?
Because both y and x are negative.
Both y and x will be negative, and a negative divided by a negative would give you a positive.
So, the opposite of your reference angle would actually be sine. So it'd be sine, or it'd be the opposite of your reference angle over the hypotenuse. If that makes any sense.
The side opposite the reference angle over the hypotenuse. Yes. Yep. Yep. Okay? Alright, so just a little review on that. Homework. Looks like you got a decent chunk of time, don't we? Till 21. Yeah, you got 15 minutes. You can get a lot of this done, because I think it goes pretty fast. Homework, page 280. 30, 37, 41, 45 to 47, 52 to 57.